Welcome to class for today, the 19th of January. Unfortunately, I am unable to meet with you live today, so we have a recording to make sure that we can make it through our lesson. If you have questions or you would like a further explanation of any example you see today, you're welcome to join me in office hours from 3 to 4 o'clock. You'll see that on your plan. It is optional. However, after you watch the video or as you're watching the video, if you have any questions, please don't hesitate to come join me in that office hours to ask your questions. You don't have to stay for the whole hour if you don't want to, just to ask your question and leave or say hi or whatever you need to do. I'll be there. So you'll see that on your plan as an optional office hours for today, Wednesday, January 19th. You're welcome to join me if you wish. Today's lesson is posted to OMHS, so as its key, we're going to be covering parallel lines, proportional parts of triangles, and proportional parts of similar triangles. Okay, so the first theorem that we're going to talk about is the triangle proportionality theorem. As we go through the year, please note, I don't really care if you know what the name of the theorem is. I care that you know what it says. Okay, so even on an assessment like an SOL, they're most likely not going to call it the triangle proportionality theorem. Whatever the reason would be that you would have to choose from would literally be its definition. Okay, so the name doesn't really make a difference. It's as long as you know what it says and you can use it. So if a line is parallel to one side of a triangle and it intersects the other two sides, then it divides the sides into segments of proportional lengths. So what that means that if in this triangle DE is parallel to AC, hold on a second. There we go. So if DE is parallel to AC, then it's splitting your sides proportionally, meaning you could write the fraction BD over DA. That would be proportional or equal to BE over EC. I like to think of that interior parallel line as like the fraction bar. So whatever this length is over this length will equal this length over this length. The converse of that is also true. Oh, there's that word converse. Remember, the converse takes your P and your Q and flip-flops it. So in other words, if the sides are proportional or split proportionally, so if BD over DA is equal to BE over EC, then your lines will be parallel. DE would be parallel to AC. Sometimes it's easier to understand what it's saying when you see an example. So let's look at one. So here in number one, we have some parallel lines. According to this triangle proportionality theorem, these parallel lines are splitting the triangle proportionally. So think of that interior parallel line as your fraction bar. You could say 14 over 12 equals x over 15. You could have also said 12 over 14 equals 15 over x. Either way, when you cross multiply, you get 12 times x and 14 times 15. And 14 times 15 is 210. And of course, divide both sides by 12, and x is 17.5. Okay, so if you see parallel lines, it is splitting your triangle sides proportionally. Go ahead and try number two. Set it up and see what you get. Try that one now. Did you get x equals 48? If you set it up slightly different than I did, but you still got 21x equals 1008 and you cross multiplied, then you still set it up correctly. There are a few ways to set this up and they're all correct. The one way you would not want to set this up, you would not want to relate 18 to 56. So if you said 18 over 56 or x over 21, that you wouldn't want that. And if you go from 18 to x, then you would start with 21 on the top and go to 56, or vice versa. But another way you would not want to set this up, you would not want to say 18 over x and 56 over 21. That wouldn't work either. But if you cross multiplied and you got 21x equals 1008, then your setup was correct. Good job. And they will try to get a little tricky on you. It's okay. I don't think any of these tricks are all that challenging. I think you can handle it. Remember way back in Unit 1, we learned the segment addition postulate? Okay, and that what that said was you have a small segment, you add it to another small segment, and you get the big segment. We're going to use that idea to find the length of this little piece right here. If the whole thing is 55 and this piece is 45, well, then we know that this piece would have to be 10 because 10 plus 45 equals 55. And now once we know that, we can set up our proportion, x over 36 and 10 over 45. And cross multiply. 45 times x is 45x. 36 times 10 is 360. Divide both sides by 45. We get 8. Okay. Use that idea in number 4. Solve for x in number 4. Try that one now. Okay, you should have gotten x equals 24. 7 corresponds to x and 6 corresponds to the 21. So when you set up your proportion and cross multiply, you end up with 6x equals 147. Divide by 6, and there's your 24. Some problems will have a little bit more algebra in them, but nothing we can't handle. So in number 5, think of that parallel line as your fraction bar. 30 over x plus 7 equals 25 over 15. And remember, as soon as you see an expression, you're going to put parentheses around it so you don't forget to distribute. So we'll have 25 times x plus 7 equals 30 times 15. And 30 times 15 is 450. I'm going to distribute that 25 to my parentheses. So I get 25x plus 175 equals 450. Subtract 175 from both sides and divide both sides by 25. So we get x equals 11. All right. So in number 6, we have a similar idea. You have 2 expressions here. So when you set up your proportions, don't forget to put parentheses around both of these guys. Go ahead and set it up, distribute, and solve for x. Let's see what you get. Try that now. So you should have gotten x equals 9. So even though you had 2 expressions here, when you cross multiplied, you still ended up with, just x's. So you distribute your 6, you get 18x minus 6, distribute your 21, 21x minus 21. In this step, I actually subtracted the 18x and added 21 in the same step. If that's too much to do in one step for you, you are welcome to do it in multiple steps. However, it helps you solve it correctly. You should get x equals 9 at the end. All right, now the next page is almost the same kind of problems, but what we're doing now is we're determining whether or not that interior line is actually parallel to a side of the triangle. They're not telling me it's parallel, we have to decide that. So we're going to use that converse. We're going to look to see, are the sides actually split proportionally? And if they are, then we have parallel lines. If they aren't, no parallel lines. So let's look at the first triangle here. I'm going to picture MN as my fraction bar, and I'm going to say, well, okay, 11 over 15.4 would have to equal 10 over 14. If that is true, I've got parallel lines. So we can use our calculators and we can simplify the fraction. 11 divided by 15.4 as a fraction is 5/7. And 10/14 reduced is 5/7. That works. So yes, these are parallel. MN is parallel to JL in this picture. Looking at number 8, I want to know, is MN going to be parallel to JL? So think of MN as your fraction bar. 15 would go to 4 and 18 to 5. And we'll reduce those fractions. 15/4, well, that doesn't reduce, it's still 15/4. And 18/5, it doesn't reduce either. Now these aren't the same fraction. So these would not be parallel. Okay? So they'll be parallel if the sides are split proportionally, not parallel if the sides are not split proportionally. Sometimes you might have to use that segment addition postulate, like here, number 9. You're going to have to figure out what is the length of JM, and then set up your proportion and determine whether or not MN is actually parallel to JL. Go ahead and try this one. What do you think? MN parallel to JL. Try it out. Try that now. You should have gotten yes, they are parallel. When you subtract 54 minus 24, you see that the length of JM is 30. So when you set up your proportion, you'll have a 30 over 24 and a 37.5 over 30. It's possible that you had it flip-flopped. Maybe you put 24 over 30 and 30 over 37.5. That's okay too. As long as those fractions reduce to the same number, as long as those fractions are equal, then MN is parallel to JL. So now the next idea, it sounds different, but it's actually pretty much the same thing we just did. It says if 3 or more lines, or 3 or more parallel lines, intersect 2 transversals, then they cut the transversals proportionally. This is just kind of like a continuation of what we've been doing, because if I continue these transversals, if I drew them straight, you would see that we actually have a triangle. So that triangle proportionality theorem is still in play, right? Because it's really just a triangle if those transversals were to keep going, and parallel lines are going to break it proportionally. Okay, so what that are, we'll fill in the if-then statement here. There we go. All right, so if we have 3 parallel lines this time, so we'll say if AB is parallel to CD, it's parallel to EF, then AC over CE will be equal to BD over DE. Still think of that interior parallel line as your fraction bar. So looking at number 10, I've got 3 parallel lines. Think of that interior line as your fraction bar. So 45 over 18 will have to equal 52 over x. Cross multiply. 45x equals, see, 18 times 52 is 936. Divide both sides by 45, 20.8. If you get a decimal on your assessment, it will tell you what to round it to. It'll say to round it to the nearest tenth, most likely. If it's a word problem, which I don't know if we've seen any word problems yet, but usually word problems have you round to the nearest whole number. Just read the directions carefully and make sure you're rounding correctly so you can get full credit when entering your answers on an assessment. All right, number 11, is you're going to set it up the same way. Think of that interior parallel line as your fraction bar. Number 12, same setup, but you're going to have to figure out what the length of this missing piece is. Knowing the whole thing is 32 and this piece is 18, you should be able to figure out that missing piece. And same over here, number 13, 3 parallel lines, 2 transversals. This whole length here is 92. This piece is 28. So you should be able to figure out this missing piece here and set up your proportion. Go ahead and try number 11, 12, and 13. Try those now. So for number 11, you should have x equals 35, 12, x equals 21, and 13, x equals 72. Perhaps you set up your equation slightly different than mine. Maybe you flip-flopped your fractions. That's okay. Check that cross multiplication step. If after you cross multiplied on number 11, you got 2x or 12x equals 420, awesome. If on number 12, after you cross multiplied, you got 18x equals 378, you set it up correctly. And in number 13, if you cross multiplied and got 28x equals 2016, then your setup was right. Even if it's slightly different than mine, it's okay. All right, number 12, 13, 14, and 15 are more practice for you. I'm gonna let you practice, wait a minute. That's funny, we just did 12 and 13. So I guess we can skip those because we already did them. Let's look at 14 and 15. 14 and 15 have a little more algebra with them. So in number 14, think of that interior parallel line as your fraction bar. 24 over 18, 3x plus 1 over 12. When you see that expression, put it in parentheses. Cross multiply 18 times 3x plus 1. 24 times 12 is 288. Distribute your 18. 18 times 3 is 54. I'm going to subtract 18 from both sides and then divide both sides by 54. So there it is. In number 15, think of that interior parallel line as your fraction bar. You're going to set up your equation. Don't forget your parentheses so that you distribute and solve for x. Try number 15 now. All right, so your 2x plus 2 corresponds to the 21, and x plus 3 corresponds to your 12. When you cross multiply, you'll have a 21 times x plus 3 equals 12 times 2x plus 2. Distribute and solve for x. You should get x equals 13. All right, so now there are some parts of similar triangles. Some of this vocabulary should be familiar to you. Hopefully you've learned this vocabulary before. Just in case, I'm going to go ahead and write it out here on the left. In a triangle, when you have a line that connects a vertex to the opposite side and makes a right angle, these are called altitudes. If you have, oh, this one should be familiar, a line that splits an angle into two congruent parts, those are angle bisectors. And if you have a line that connects a vertex to a midpoint of the opposite side, we call that a median. Hopefully that vocabulary is familiar from a previous math class. What's important to know is all of these lines, the altitudes, the angle bisectors, the medians, they will all split your triangle proportionally. So if you have an altitude in your triangle, it's going to split your triangle proportionally, where the altitude of one triangle here will be proportional to this altitude. So I can say that BD over FH will equal, and then you could pick, like here we'll say AB over FE, or I could have said BC over FG. So I'm going to say BA over FE. For my angle bisectors, that angle bisector here, and there's an angle bisector over here. So these two triangles are now proportional, and we can say that QS, the angle bisector in the first triangle, will be in a fraction with UW, the angle bisector from the second triangle. And QP will be proportional to UT. So the sides. If you have medians in your similar triangles, then those medians will be proportional. So you can say HJ over LN, and then you can relate two of the sides. How about GH and KL? All of these work as long as the two triangles are originally similar in the first place. So if two triangles are similar, so this triangle is similar to this one, then their altitudes will be proportional to, and their corresponding sides will be proportional, clearly, because they're already similar. Your angle bisectors will be proportional, and your medians will be proportional. So if you're given two similar triangles, then you've got all these new proportional parts. So for example, in number 1, they're telling me the triangle STU is similar to triangle DEC. As soon as I know that those triangles are similar, I know that all of their sides are corresponding. And with that new theorem that we just learned, that means that their medians are proportional, their altitudes are proportional, and their angle bisectors are proportional. In number 1, I'm looking at medians because I have a line going from a vertex to the midpoint of the other side. So these are medians. Not that that really matters. But then we can say, oh, well, this median will be proportional to this median, so X will go to 15. And then we've got some options here. You could say 16 will be proportional to 20, or you could say 19.2 proportional to 24. Either one, just pick one. I'm going to say 16 over 20. If you had said 19.2 over 24, you're going to get the same answer. Cross multiply, 20x, and 15 times 16 is 240. Divide both sides by 20, x equals 12. Let's look at another one. In number 2, the two triangles are similar already. It tells me that. So that means In this case, the altitudes are going to be proportional. Remember, a line that goes from a vertex to the opposite side and is perpendicular is called an altitude. So this 10 will be proportional to that 8. And so this x will be proportional to 14. And if you're ever not sure, look at the letters, right? So x is on IH, here's IH, so that's going to have to be proportional to LK, and LK is 14. Cross multiply, divide by 8, 17.5. In number 3 and 4, the idea is the same. If you have angle bisectors, altitudes, or medians, they will be proportional when the triangles themselves are similar. So go ahead and see if you can solve for x in number 3 and solve for x in number 4. Try those now. Right, so for number 3, you should have x equals 28.5. And in number 4, x is 33.6. Looking at number 4, you notice that the altitudes are on the outside of the triangle. That happens in an obtuse triangle. Altitudes are allowed to be outside the triangle as long as they are touching one vertex and they're perpendicular to the opposite side. Number 5, we have more medians, a little more algebra this time because instead of an x, we have expressions, but that's okay. The idea is the same. The medians are going to be proportional. So the median in the first triangle is 20 and the median in the second triangle is 12. YC corresponds to LH. I can look at the name for that if I need to. YC is 2x minus 9 and LH is x minus 2. Don't forget your parentheses so you don't forget to distribute. 20 times x minus 2 will equal 12 times 2x minus 9. Distribute your 20. Distribute your 12. Let's see, 12 times 9 is 108. I'm going to subtract 20x from both sides and add 108 to both sides. So I get 68 equals 4x. Divide by 4, 17. And we have one other theorem to talk about. It says the triangle angle bisector theorem. It says an angle bisector in a triangle separates the opposite sides into two segments that are proportional to the length of the other two sides. So in this example up here for our definition, that means that here AD, this piece, will be proportional to this piece. So AD over DC, it's a D, will be proportional to AB over CB. There's just lots of proportionality happening when you have some similar triangles. So in this triangle, it says if KM represents an angle bisector. So KM is the angle bisector in all of these. Okay, you could think of that angle bisector as the fraction bar. 14.8 over, or 4.8 over x would be equal to 12 over 18. If it helps to visualize that angle bisector as your fraction bar, go for it, because you could do that and it'll help you set it up correctly every time. 4.8 times 18 is 86.4. Divide by 4 or 12, 7.2. Try number 7. KM is the angle bisector. Set up your fractions and cross multiply. Try number 7 now. All right, hopefully you got 48.6. You could have said 40 over 36 equals 54 over x, or you could have said 36 over 40 equals x over 54. In number 8, we need to find the length of LM. I know that LJ is 39 and JM is 15. So if I just subtract 39 minus 15, I get 24. Now I have everything I need to set up my proportion. I could say 15 over 24 equals x over 36. You could have also said 24 over 15 equals 36 over x. Either way, when you cross multiply, you get 24x equals 540. Divide both sides by 24, you get 22.5. Now, number 9 is a tricky one. And there's 2 ways to do it. I'm going to do it the least algebraic way first, and then I'll show you the algebra way too. And the reason why I say it's a little trickier is because JL is X. It doesn't tell us the length of JL. And so usually we would take that whole length and subtract 12 to find the length of LM. But I can't do that here. So what I'm going to do actually is I'm going to find the length of LM. I'm going to call it Y, a different variable. So now I can say 12 over Y equals 18 over 30. And I can cross multiply. 18Y equals 30 times 12, 360. And then divide by 18, 20. So Y equals 20. We didn't answer the question yet though, because it wanted us to find X. So if Y equals 20, X will be the sum of 12 and 20. So that means X equals 32. That's the slightly less algebra-like way to do it. If you're looking for the more algebra-like way, what I would do is I would say, okay, to find the length of LM, I would take the whole length and subtract 12. The whole length is X. So I could call length LM X minus 12. That's the whole thing minus this piece. And then I would say that 12 over X minus 12 equals 18 over 30. And when you cross multiply and solve for X here, you'll get the same answer, 32. If you don't like that way, that's okay. Do it the first way I did here in green. Just find the length of ML first, give it a different variable name like Y, solve for it, and then use it at the very end to find X, what you were looking for in the first place. All right, go ahead and try number 10. Try number 10. Set it up, cross multiply, solve for X. Do that now. And you should get X equals 17. So when you subtract 45 minus 27, you get 18. So you can say 27 over 18 equals 3x minus 9 over x plus 11. Distribute and solve for X. You're welcome to check your work here with mine if you didn't get 17. And that takes us to the end of the lesson. So again, if you have any questions, you are welcome to come join me during office hours. Today, January 19th, from 3 o'clock to 4 o'clock, you'll see an optional neuro assignment on your schedule. You're welcome to join me and ask me any questions you have. Don't forget to do the exit quiz or the exit ticket. The exit ticket is available to you, as well as your attendance quiz. The attendance quiz word was given during the play posit, so hopefully you got that. And I hope you have a wonderful day, and I really hope to see you live next week. Bye all.